For 7.3, we are going to be talking about fractional exponents. So, recall from chapter 3 that the nth root of x to the n equals x to the first. How do we get 1 using the n and the n? Well, wouldn't it be x to the n over n? Wouldn't that be equal to 1? That would indeed be equal to 1. So the cubed root of a to the third is equal to a to the first, or a to the 3 over 3. The fourth root of 13 to the fourth we know is equal to 13 to the first, or 13 to the 4 divided by 4. So you should remember that you take the exponent divided by the root, and that tells you whether it's a perfect cube, perfect square, perfect fourth root. And if it is, you're supposed to divide those. So we could also just say that the cubed root of a to the third, though, is equal to a to the 3 divided by 3. So consider radical 5. Now, radical 5 could be written as square root of 5 to the first. Now, I know that 1 divided by 2 is not perfect, but if I wanted to write this using a fractional exponent, I would say 5 to the 1 divided by 2, or 5 to the 1/2. So the square root of 5 is equal to 5 to the 1/2. These radical fractional exponents are going to be important down the road. So we're going to start learning the basics of them now. So then that brings us to our rules here. In general, we can say that square root of x to the first is equal to x to the 1 over 2. The cubed root of x to the first is equal to x to the 1 over 3. The fourth root of x to the first is equal to x to the 1/4. So the nth root of x to the first is equal to x to the 1 over n. So in our examples, the cubed root of 64 to the first would be 64 to the 1/3. And we're not simplifying it right now. I know that's equal to 4. We're just learning how to write it as a fractional exponent. The next one is the fifth root of 32 to the first, a to the 5th. So that would be 32 to the 1/5, a to the 5/5. And that one we can do a little bit more, 32 to the 1/5, a to the 1st. So also, we should note then that we have the nth root of x squared is x to the 2 over n. The nth root of x to the third would be x to the 3 over n. And the nth root of x to the fourth is x to the 4 over n. So therefore, the nth root of x to the m, or the nth root of x raised to the m, is equal to x to the m divided by n. I sometimes also write it out like this. Here's the power, here's the root. The root of a tree or bush or plant is at the bottom. So the power is on top, the root is on the bottom. Okay, so the rth root of x to the p equals x to the p divided by r. So for example, our roots is 3, that's going to be on the bottom. Our power of 2 is going to be on the top. The fifth root of 3 to the 7th, the root is on the bottom, power on the top. The fourth root of x to the 6th, the root is on the bottom, the power on the top. And we could even simplify that to 3/2 if we wanted. Now remember, I'm not trying to simplify those any further. I'm just looking at writing them as fractional exponents. And then there's a doctors and nurses rule. Numerator from power is an NP. Denominator from root is a DR for doctor. I like my little plant scenario, but you can use doctors and nurses rule also. All right, some other examples. Express each power in simplest form. So 25 to the 1/2, you should then realize is the square root of 25. So that root was on the bottom, goes on the outside, and the power on the inside. And then what is the square root of 25? 5. Okay? Number 2, that would be the root is 3, put that on the outside, the power. Now for these, it's almost easier to take the root part first and then the power last. So I always put those in parentheses squared. The cubed root of 64 is 4, and then 4 squared is 16. For number 3, 27 to the 5/3 is 27. That root is 3. The cubed root of 27 is 3, and 3 to the 5th is equal to 243. That's much easier than trying to do the cubed root of 27 to the 5th. Yikes, 27 to the 5th? That's really big. Okay? This is easier. Okay, number 4. 5 to the 1/2 times 5 to the 3/2. Now we need to remember a rule of our exponents. X to the R times X to the S equals X to the R plus S. When they have the same base, we add the exponents. So this becomes 5 to the 4/2, which is 5 to the 2nd. I'm going to put it down here, which is 25. I didn't really need to deal with radicals at all there. Number 5 is 5 to the 5/2. Okay, so this one, I'm going to again put the 5. The root is 2. The power is 5. I'm going to put it on the outside. Now, there is no square root of 5, but if we multiply this times itself, square root of 5 times 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 square root of 5, you can keep the little 2 root there, or you can put it in if you really want. You can have the little 2 there. Doesn't matter. And when you multiply a radical times itself, you get the radicand. And this, you get the radicand. So we get 5 times 5 radical 5, which is 25 radical 5. Number 6, 9/16 to the 3/2. So I'm going to again take and put the 2 on the outside, the 9/16. It's the root, square root of 9/16 to the 3rd. And these are perfect squares. So do each one separately. The square root of 9 is 3. The square root of 16 is 4. And then I want 3/4 to the 3rd, which I just want 3 to the 3rd, 4 to the 3rd, which is 27 over 64. Back up. Number 7. Now we have a negative exponent. So we have to remember the rule. If we have x over y to the negative n, that becomes y over x to the positive n. So that's the first thing I'm going to do, is make this 16 over 9 to the positive 3 over 2. And then from there, that's the square root of 16 over 9 cubed. And the same thing, we're going to take the square root of 16/9, which is 4 and 3, and then we're going to cube that. So we're going to cube the 4 and cube the 9. So it's just the reverse of number 6. Number 8. Now for this rule, I should remember that x to the r divided by x to the s equals x to the r minus s. So I'm going to do 27 to the 4/3 minus 2/3. And that equals 27 to the 4 minus 2, which is 2/3. And then I'm going to simplify that. So that is the cubed root of 27 squared, which is 3 squared, which is 9. Number 9, 125 to the negative 1/3. Remember, with our negative exponents, it's 1 over 125 to the positive 1/3. And then that becomes 1 over the cubed root of 125 to the first, which is just the cubed root of 125, which is 1 over 5. Number 10, we want to do the multiplication second. We want to do the exponent first. So 6 times 27 to the 1/3 would be 6 times the cubed root of 27 to the first, which is 6 times 3, which is 18. Okay, number 11. So, with number 11, what you can do is you can multiply the 2.5 and the 7.3. I'm not going to do FOIL here because it's not that kind of problem. But 2.5 times 7.3, let me change that to a better decimal point. So we can do that times 10, and then we can multiply those together. Now they have the same base, so I can add those exponents. So it's negative 1/2 plus negative 3/2. So 2.5 times 7.3 is 18.25. And then negative 1/2 plus negative 3/2 is negative 4/2, which is really just negative 2. So I'm going to have to, I think, take this one down below here. I'm running out of room. So I have 18.25 times 10 to the negative 2. Okay, at this point, we could convert this to scientific notation, or you could actually divide it if you want. 18.25 times 10 to the negative 2 means that you would take the decimal point and move it 2 places to the left. So it becomes 0.1825. So that's an answer for that one. Or if you put that back in scientific notation, it's 1.825 times 10 to the negative 1. So it all depends on what the question is asking. I have it kind of in simplest form there. Next page, number 13. Write each radical expression as a power with a positive exponent in simplest form. So we need a radical expression as a power, positive exponents. Okay, so this is really a 2 and a 7 to the first. So remember, that's 7, root on the bottom, power on top, 7 to the 1/2. 14 is the 4th root of 3 to the first. You can put it on the inside or the outside. And so that's equal to 3, root on the bottom, power on the top, 3 to the 1/4. 15, I'm going to do some simplifying here. This is already in radical form. I'm going to do some simplifying and then put it as fractional exponents. So 1/2, I'm going to put my perfect squares, my non-perfect squares. So I have 9a to the 6, b to the 2nd, and 2. So I get 1/2 times 3a to the, now remember the root here is a 2, so we take 6 divided by 2, So this is a to the third, 2 divided by 2, b to the first, radical 2. So kind of putting it all together here, we have 3a cubed b times 2 to the 1/2 all over 2. Now, I'm thinking that maybe I could do something with the 2 to the 1/2 over 2 to the 2/2. But did it say positive exponents? So if I were to subtract these exponents, 1/2 minus 2/2 would give me negative. So I'm going to leave it in this form. 16 is 5 times the square root of x to the first, which is 5 times x to the 1 over 2. $17 is 125 to the 1/3 and a to the 3 divided by 3, which is 125 to the 1/3 a to the first. I'm going to simplify that like that. And I suppose we could even take that further and say that that's just 5a. Cubed root of 125 is 5. Next one is square root, and I've got a negative exponent. So first thing I'm going to do is get rid of that negative exponent. So I'm going to go 16 over 25 a to the 4th b to the 2nd. And then everything's a perfect square, so that one I just simplify. So 4 over 5a squared b. 19. Okay, now we have 1 divided by x to the root on the bottom, 2/5. This is really y to the first in here, so it's y to the 1/5. And that's it. I have power with positive exponents. I think I'm in simplest form. There's nothing. I don't want negative exponents, so I'm good. On number 20, we have the cubed root of 5x squared, so that's going to be, this is 5 to the first inside here, so that's going to be 5 to the 1/3 x to the 2/3. 21, the 5th root of x to the 4th y to the 3rd is going to be x to the power over that root, y to the power over the root. So x to the 4/5, y to the 3/5. Last three. 22, write each power as a radical expression in simplest form. The 6 to the 1/3 is the cubed root of 6, and we cannot simplify that any further. That would be a decimal. The next one, 23, is really equal to the square root of 50ab to the 4th. You could do something else differently with that 1/2. You could distribute it, but I think this is going to work out the best. Then I'm going to do my perfect squares and my non-perfect squares. So 25b to the 4th and 2a. And that's going to equal 5b squared radical 2a. On 24, we have, okay, for number 24, that is the root, square root of 6 to the 5th. So just like the other one, we're going to take the square root of 6 times the square root of 6 times the square root of 6, 5 times. Radical times itself is the radicand. So we get a final answer of 36 radical 6. And on 25, so this is all to the 6th. So for the top, it's a sixth root, 8 to the first, a to the fifth, b to the third, and in the denominator it's also a sixth root because it's in parentheses, 27 to the first, and c to the fourth. So, putting it all together, I suppose we could say we have the sixth root of 8, a to the fifth, b to the third, divided by 27c to the fourth. And I do not believe that anything inside there simplifies. Don't worry about rationalizing that denominator. That's a little bit crazy. All right, and that ends that.